Assalamualaikum warahmatullahi wabarakatuh. This is our mathematic project. The title is Continuity and Discontinuity. My lecturer name is T.S. Dr. Geda Pramudya Ananta. We are from section 1. We have 4 group members. First, my name is Nurul Madiha binti Muhammad Syabki. Second, Azmira Izani binti Azman Arif. Third is Siti Nur Aisyah binti Amir Baki. The lastly is Aina Alisha binti Zaidi. Let's go to the part A. First question is define continuity and discontinuity. Continuity. A function f(x) is continuous at a point x equals to a if all 3 conditions are satisfied. First, the function is defined at that point f a exists. Second, the limit exists. Limit f x exists. Third, the limit equals the function value. If all 3 are satisfied, the graph has no breaks, holes, or jumps at that point. A function is continuous everywhere if it continues at every point in its domain. Discontinuity. A function is discontinuous at a point when at least one of these occurs. First, the limit does not exist. Second, the left and right hand limits are not equal. Third, the function is not defined at that point. Fourth, the limit exists but does not equal the function value. So, this creates a break jump gap in the graph. Explain the type of discontinuity. First, removal discontinuity happen when the limit exists. Second, but the function is not defined at the point or defined incorrectly. The graph has a hole. B. Jump discontinuity. Left hand limit and right hand limit are not equal. Graph suddenly jumps. Common in piecewise or step functions. So left limit is equals to 2 and right limit is equals to 5. C. Infinity discontinuity. The function is approach plus infinity or negative infinity. Occurs at vertical asymptotes. The lastly at x equals to 0, infinity discontinuity. Okay, lastly, the oscillating discontinuity. Function oscillate infinitely fast near a point. Limit does not exist because value keep changing. So, as x equals to 0, that can be infinity oscillations.
Assalamualaikum and good morning everyone and Segede. My name is Siti Nur Aisyah binti Muhammad Amir Baki and number matrix DB240152. Today I will explain about the intermediate value theorem or IVT part A. So, IVT states that if a function f of x is continuous on a closed interval from a to b, that is square bracket a comma b square bracket, then for any value k between the outputs at the endpoints, the function must reach that value at least once within the interval. To illustrate, consider f of x equals x cubed minus x minus 2 of the interval from 1 to square bracket 1, 2 square bracket. First, we evaluate the function at the x points. f of 1 equals 1 cube minus 1 minus 2 equal negative 2, and f of 2 equals 2 cube minus 2 minus 2 equal 4. We are looking for a root, so we choose k equals 0. Notice that 0 lies between negative 2 and 4. Since the function is continuous on square bracket 1, 2 square bracket, IVT queries that there exists some c in open interval 1, 2. That is parenthesis 1, 2 parenthesis such that f of c equals 0. That's all for me. Thank you.
Define continuity and discontinuity. Continuity means a function is smooth at a point and it has no breaks, no holes, and no jump. A function is continuous at x, a if the limit of fs as x approaches is equal to the actual value fa. Discontinuity is when this condition fails, meaning the graph is broken, has a jump, goes to infinity, or has a hole. Number 2, types of discontinuities. There are 4 main types of discontinuities. Number 1 is removable. The limits exist, but the function value is missing or wrong. Graph has a hole. Next is jump. Left limit and right limit are not equal. Graph suddenly jump to another value. Infinite. The function goes to positive or negative infinity near a point. Next, oscillating. The function shakes or oscillates rapidly near a point, causing no limits to exist. Number 3, intermediate value theorem. The intermediate value theorem states that if a function is continuous on a closed interval, then for any value fa and fb, the function will take that value at least once. This theorem basically says a continuous graph cannot suddenly skip values. Number 4, how do limits relate to continuity? Limits determine whether a function is continuous. If the limit of fx as x approaches and equals the actual value fa, then the function is continuous. If the limit does not exist or does not match fa, then the function is discontinuous. Next is function analysis. Number 1 is rational function example. For the rational function, the denominator becomes 0 at x is 2, so the function is undefined there. However, the limit as x approaches 2 is equal to 4 because the limit exists but the function is not defined. This is a removable discontinuity. We can fix it by defining f2 is 4. Next is piecewise function example. For the first function, which is a piecewise function, we analyze continuity at the joining point. I check the left hand limit and the right hand limit at x is 1. The left limit equals 3 but the right limit equals 1. Since the two limits are different, the function has a jump discontinuity at x is 1. Next function is trigonometric. For the trigonometric function tan x, we know that tangent blows up to infinity at x is pi per 2 and every pi interval. At these points, the function goes to positive or negative infinity. So the tan x has infinite discontinuities at those points.
Assalamualaikum and good morning everyone. Today I will present about continuity and discontinuity of some function. We will look at 3 examples and explain the point of discontinuity. The first, we consider the rational function f of x equal open bracket x minus 3 close bracket time open bracket x plus 3 close bracket over x minus 3. This function simplifies to f of x equals x plus 3 for x not equal to 3. However, there is a discontinuity at x equals 3 where the function is undefined. The graph shows a smooth curve with a gap at x equals 3, indicating a removable discontinuity even though the limit of f of x as x approach 3 is 6. The function itself is not defined at this point. Next, we examine the continuity of a piecewise function at x equal 1. The left-hand limit, that is the limit of f of x as x approach 1 from the left, is 2. The right-hand limit, that is the limit of f of x as x approach 1 from the right, is 1. The function value at x equal 1 is 1. Since the left hand limit and the right hand limit are not equal, the function is discontinued at x equal 1. Finally, we examine the function f of x equal sin x over x. This function is undefined at x equals 0. However, the limit f of x as x approach 0 is 1. Despite the limit approaching 1, the actual function value at x equals 0 does not exist. Therefore, there is a discontinuity at x equals 0. That's all for me. Thank you.
Parking price are an example of a function that has a discontinuity where the price jumps up suddenly every time a new hour starts. This creates a jump discontinuity and the graph looks like a step function. Okay, so for the example, the first one is parking rates during busy time. In places like shopping malls or office areas, parking price might suddenly increase at busy times, like lunchtime or weekends. This happens because more people need parking spot. And another example is special event and holidays. During holidays or a big event like concert or sport games, more people need parking, so price go up quickly. This is a discontinuity because the price increased sharply in a short time. Okay, so for the graph, if we look at the graph, it shows the parking price with a jump discontinuity. This price stay the same for each hour and then jumps at certain times like RM2, RM2 and RM4. This show that the price doesn't increase smoothly but jumps every time a new hour begins.
Conclusion. In conclusion, discontinuities and occur when limits from left and right are not equal, when functions are undefined at a point, or when the function value does not exist. By analyzing limits and function value, we can classify these discontinuities as removable or jump discontinuities. That's all for me. Thank you.